Hello dudes and dudettes, I am back with another video. Yeah, I sounded like a YouTuber here, but hey, who cares? So we're going to solve more organic chemistry questions for O levels and IGCSE, and it's highly recommended that you guys don't procrastinate at this stage of your examination, because this MCQ paper can either make you or break you. So please don't procrastinate, keep on working hard, keep on practicing, just join me while I practice, and yeah, that should do the job, right? And I'm currently just doing organic chemistry questions, but you guys can hit me up on WhatsApp and in the discussion forum, and send in your queries, and I'll be more than happy to help each and every one of you, because at the end of the day, all I want to do is try to spread the word of knowledge so that each and every person in his particular field gets more and more specialized, and the understanding is more conceptual. Done? So now this particular MCQ says 1 mole of alkane Y produces 72 decimeter cube of carbon dioxide when burned in excess oxygen. We already know that whenever we have a fuel and it burns in excess oxygen, it's going to give you carbon dioxide, water, and large amounts of energy, right? And if it burnt in limited fuel, then it would give you carbon monoxide, water, and small amounts of energy. Done? And the examiner has already specified the amount of carbon dioxide that you are getting. That's 72 decimeter cube. So if I were you, what I would have done is, I would first of all convert this much decimeter cube into moles, right? Because when I am making the equations, the options are given to me. So when I'm making the balanced equations, the coefficient of each balanced equation is going to represent the number of moles. So it would be better that I convert this particular volume into moles, so then I can compare it with the number of moles of carbon dioxide produced in each particular option, right? So let's convert it into moles. We know that 1 mole of any gas at room temperature and pressure occupies a volume of 24 decimeter cube. So if you have 72 decimeter cube of carbon dioxide, how many moles would there be? N cross multiply, you're going to get 72 over 24. That's going to give me 3 moles, right? So you're going to have 3 moles of carbon dioxide. Now the examiner is saying, hey, which particular option is going to give you 3 moles of carbon dioxide being produced? Now, the best way to go about it is by doing smart work and not donkey work. And by smart work, what I mean is that you already know that the number of carbons that you should have in your fuel are the number of moles of carbon dioxide that are going to be formed. What do I mean by this? Well, what I mean by this is, if you have butane, which is C4H10, and you have ethane, which is C2H6, methane is CH4, and propane is C3H8, right? Now what you need to understand is the number of carbons that you have in your hydrocarbon in this particular fuel are the number of moles of carbon dioxide that are going to form. You guys can check it out yourself. So you react them with oxygen, and what's going to happen is carbon dioxide is going to form and water is going to form. So instead of writing all the equations, I could safely select D as the option, because I know that you have 3 carbons in propane, therefore 3 moles of carbon dioxide are going to be produced, and 3 moles literally mean 72 decimeter cube, right? And you could, if you want to do donkey work, you could balance each and every option out. In this option, you're going to get 4 moles of carbon dioxide. In this, you're going to get 2 moles. In this, you're going to get 1 mole. And in this, you're going to get, obviously, 3 moles of carbon dioxide. And that's going to be equal to 72 decimeter cube. Done? Pretty easy. Next question says, the structure of organic compound X is shown. Now, if you check this compound out, it's an ester. Why? Because of the COO linkage, right? So that's my beautiful ester. And the name of this ester would be, this came from the alcohol bit and this came from the carboxylic acid bit, right? So you have 2 carbons from the acid and 1 carbon from the alcohol. So the alcohol was methanol, and therefore the name would change to methyl. And the carboxylic acid was actually that was ethanoic acid, and because now it has formed an ester, it's going to be called ethanoate, right? So the name of this particular ester is going to be methyl ethanoate. Done and dusted. So which particular option do I have? Methyl ethanoate is option number C, right? And sir, how did you know that these 2 carbons belonged to the acid and this carbon belonged to the alcohol? Well, it's pretty easy. Remember that whenever you have a carbonyl carbon, which is C double bonded to O, that particular carbon and all the adjacent carbon will be from the acid. So this carbonyl carbon was an indication that here the OH was bonded and the OH was lost, and here from the alcohol the H was lost, and obviously you got water molecule. It's a condensation reaction. So this carbonyl carbon, this carbon right here, and the adjacent carbons belong to the acid. They belong to the acid. They came from the acid, and this carbon right here came from the alcohol, right? So it's just single bonded to O. Done? Pretty easy. Next, it says, what is the structural formula of the compound formed when in an addition reaction of propene with bromine? So it's pretty easy again. We've already done the MCQ earlier, but if you check propene out, that's my C bonded to C and double bonded to C, right? Because it's propene, propene's 3 carbons, 1, 2, 3, and because it's an alkene, there's going to be a carbon-carbon double bond, right? So this is my beautiful propene structure right here. And what's going to happen is when you react it with bromine, which is Br2, the Br2 is obviously going to get decolorized. Why? Because obviously there's going to be an addition reaction taking place. This carbon-carbon double bond is literally going to break, and one Br is going to be bonded here and the other Br is going to be bonded here, right? So if I basically lasso this, boom, shakalaka, what I'm going to do is I'm going to erase this double bond. We're gonna erase this double bond because this double bond breaks beautifully, and a bromine atom is bonded right here and another bromine atom is gonna be bonded right here. Remember guys, it does not matter if you put the bromine here or the bromine here or here or here. What matters is that the new atoms that you're putting on this particular compound are gonna be in such a place where the double bond breaks. So remember, wherever the double bond is breaking, only there will you be able to add the bromine atoms or whichever new atoms you have, right? So wherever the double bond breaks, the new atoms are bonded there. And it is pertinent to note that, you can't add both the bromine atoms on a single carbon. No. If the double bond breaks, this particular carbon can now make one more bond and this particular carbon can now make one more bond. So one Br will come here and the other Br will go here. It is not possible to put both the Brs on the same carbon. That's wrong, because we already know that this carbon has already completed, this carbon right here has already completed 3 bonds. So it only needs to complete one more bond. So it can make 2 bonds with bromine atoms. Similar is the case with this carbon. Done? So if you check this out, A is absolutely correct. Why? Because obviously if you draw this Br atom is bonded to this carbon and this Br atom is bonded to this carbon. So that's pretty much correct. Now, if you check B out, B is wrong because one bromine atom is bonded here and the other bromine atom is bonded here, right? So what he's doing is he's effectively bonding one Br atom here and one here, but we know the double bond broke here, so one Br atom should come here and the other should come here. It's not possible that a bromine atom is bonded here and another is bonded here. So B is also wrong. If we check C out, C has the same mistake as I referred to earlier, that he has put both the bromine atoms on the same carbon, which is effectively not possible. And if you check D out again, he's put both the bromine atoms on the same carbon, so that's also wrong, and therefore A is the correct option. Ethanol is produced industrially by fermentation and also by a catalyzed addition reaction involving steam. Which row describes one advantage of each process? Well, we know that the biggest advantage of fermentation is that it uses glucose, which is a renewable resource, right? It's not a rapid reaction, it's actually a very slow reaction. Fermentation, that's the disadvantage. It's a batch process and it's a very, very slow reaction. So compared to obviously a catalyzed addition reaction. So C and D are wrong, and the advantage of catalyzed addition reaction is that it's a continuous process. It's very quick, continuously you're going to get your alcohol being made very, very quickly, right? It requires less energy, absolutely wrong. It requires an energy of 300 degrees Celsius, right? Compared to fermentation, which only requires energy of around 35 degrees Celsius, right? 25 to 35, done? So that's false, absolutely, man. What you on about? So A is the correct option, right? It is a continuous process and renewable. Done? Moving on. Carboxylic acid reacts with alcohols when warmed with an acid catalyst. So usually we use concentrated H2SO4 and we warm it to like 200 degrees Celsius, and he's saying which type of substance is formed. When we know when a carboxylic acid reacts with an alcohol, what do they produce? They produce an ester, and that's called esterification. So what substance is formed in this reaction? It's called an ester, dude. Next. Nylon is formed by the condensation polymerization. Remember, for nylon, you know that nylon is made up of two monomers. Number one is a dicarboxylic acid and the second monomer is a diamine, right? So what you need to do is you need to put a cut at the ester, not the ester linkage, you need to put a cut at the linkages to find out both the monomers, to find out whether which structure is of nylon, right? So let's put a cut at the linkages here. We know that this is my amide linkage right here, C double bonded to O, NH, C double bonded to O, NH. So we put a cut at the linkage, put a cut at the linkage, put a cut at the linkage, and between at the connectivity bonds again, put a cut. I don't even know what this is. This isn't even a new linkage, but let's put a cut here, let's put a cut here, let's put a cut here. Let's put a cut here at linkages, at the linkages. Put a cut here, Yeah, that's pretty much all the cuts that we need to put, right? These are the linkages. Now, between two cuts, you're going to get your monomer, right? So if you check this out, pretty easy. Between two cuts, you're going to have your monomer. So this right here is my monomer uno, between two cuts, and this right here is my monomer dos, and that's not actually nylon, that's actually a protein. Why? Because this is an amine group and that's an acid group. So this is amino acid and another amino acid. So potentially A is not a nylon, A is basically protein, right? That's protein right here. If you check B out, B again is a structure of protein. Why? Because again between two cuts you're going to have your monomer and it's an amine and an acid, right? So it's amino acid. So again B is also the structure of protein. If you check C out, C is absolutely nylon. How do I know this? Well, pretty easy. Check this out. You have your beautiful diamine and you have your beautiful dicarboxylic acid. So diamine and dicarboxylic acids were the monomers of nylon, and therefore C is correct. Remember guys, I'm going very slow. I'm basically dumbing it down to such an extent for a student who may not be able to, maybe the student is not able to grasp organic chemistry, so I'm trying to dumb it down to the maximum extent possible, or else just by looking at these structures you would have understood that C is the correct option. So there are tricks and tips about it, but I'm just going to focus on the main simplified version of it. Again, D doesn't even make sense, I don't even know what D is, to be honest. Neither should you, These are the monomers, who cares what it is. We know that there's this ester linkage right here, but who cares what this is, right? Next, which structure represents the repeat unit of an addition polymer from but1ene? So if it's but1ene, remember that's meth, eth, prop, but. So that's but1ene. How do I know this but1ene? Because the double bond is between the first and second carbon. Therefore, it's going to be but1ene. If it were in the middle, then it would be but2ene. So that's but1ene. Now, what you have to do is, because it's an addition polymer, we put a cut after every two carbons in the straight chain. So put a cut after every two carbon, put a cut after every two carbon, put a cut after every two carbon, put a cut after every two carbon. Remember, between two cuts, you're going to have the monomer. So this is meth, eth. This is ethene. This is not even but1ene. So D is wrong. If you check this out, this again is meth, eth. This is ethene. And this right here, God knows what this is, right? So it's one carbon here and one carbon here, but you have to check the straight carbon, the straight chain carbons, right? So that's also a messed up structure with me, because between two cuts you don't have four carbons, you don't have four carbons between two cuts, you only have two carbons right here, done? And here between two cuts you have four carbons, 1, 2, 3, 4, and here as well you have 2, 3, 4. So between A and B now you have to select which one is but1ene. If we draw B out, it's basically CH3 bonded to C, bonded to C, bonded to CH3. And because you've put a cut at these two linkages, you've put a cut here and a cut here, this cut is going to go back into this double bond. So a double bond is going to form right here, right? And similar is the case with this particular molecule. You have C bonded to C and you have C2H5 right here. So wherever you've put the cut, this particular cut, now this bond is no longer there. Now this bond is no longer there. So instead of these two bonds, a double bond forms again. So a double bond forms right here. Check this out, name it. This is meth, eth, pro, but, and because the double bond is between the first and second carbon, this is but-1-ene. And if you look at this, it's meth, eth, pro, but, but the double bond is between the second and third carbon. So that's but-2-ene, and this is but-1-ene, and the examiner asked but-1-ene. Therefore, A is the correct option, B is wrong. Okay, let's look at this particular MCQ. It says which compounds are in the same homologous series, which means which compounds belong to the same family. Now, there are many ways to verify them. One of the major way is to write down their molecular formula and check whether they all fit the same general formula, because we know for a homologous series they must have the same general formula, they must have the same functional group, and so on and so forth. And right off the bat, just by talking about functional group, I can eliminate C off. Why can I eliminate C? Pretty easy, because here I saw an alcohol functional group and here I saw a carboxylic acid functional group. Because the functional group is not the same, they don't belong to the same family. One is the alcohol family and the other one is the carboxylic acid family. So you have to be very vigilant in these things, right? You have to look at it from a zoom out perspective. And similar is the case with D. I can quickly eliminate D off because this CH is indicating that here you have a double bond, right? So because you have a double bond, therefore I could safely cancel out D, because this particular molecule is an alkane, that's an alkane, and that's an alkene. If I show it to you guys, you can absolutely see it. This is CH2 bonded to a CH, which is bonded to CH2, which means that this CH2 right here, this CH2 and this CH have a double bond. Why? Because it can't be that a carbon has made 3 bonds, and it can't be that a carbon has made 3 bonds. So there must be a double bond. Where would it be? Between these two carbons, right? So let's draw the double bond. So this fella right here, this belongs to the alkene family, and these fellas, these two fellas, they belong to the alkane family. And you can also verify it by just looking at the molecular formula. So you can say, hey, you have 3 carbons, so you have C3, and here you have 3 plus 2, 5, 5 plus 3, you have 8 hydrogens, right? So that's an alkane, and this is an alkene, right? Done. Now between A and B, let's check it out. I think B makes sense to me. Absolutely it does, because again in A what they have done is they have had an alkane function, an alkane family and an alkene family. So how are you so confident? Because I know my structural formulas. Here he is shown a double bond, whereas here he only has single bonds, right? So I can show it to you. CH3 bonded to C, bonded to H, bonded to C, bonded to H, bonded to CH3. Now check it out. It's very logical. How come a carbon has only made 3 bonds? How come this carbon has only made 3 bonds? It must be that there is a double bond between them. So again, that's my meth, eth, pro, but. That's but-2-ene, whereas this is meth, eth, pro, but. This is butane, right? And you could draw it and check it out. So A is wrong and B must be the correct option, because that's an alkene, that's an alkene, that's an... by just looking at the CH, you could safely deduce that there's a double bond. CH, CH, right? That's how I found out that here there was a double bond, here there's a double bond, and obviously here there's a double bond. Yeah, and similar is the case with this and this. Last 2 MCQs, peeps. Zion. The diagram shows 4 structures of C4H8. Which structure represents the same molecule? Well, again, your isomerism should be pretty strong here, and you can safely find which 2 structures are the same if you know how to name them. So if we check the name of this structure, this is same. It's meth, eth, pro, but, and because the double bond is between the first and second carbon, it's going to be but-ene. But because the double bond is between the first and second carbon, we're going to insert the smaller number. So that's but-1-ene. If you check this out, select the longest unbroken carbon chain, start numbering from the side where the double bond is the closest. This is 2-methyl. On the second carbon you have the methyl group right here. That's methyl. So it's 2-methyl meth eth prop. It's 2-methyl prop 1-ene. Done. So 2 and 1 are not the same. Check 3 out. This is meth eth prop but, but you start numbering from the side with the double bond is the closest. 1, 2, 3, 4. It's the same from both the sides. So it's but 2-ene because the double bond is between the second and the third carbon, so the 2 is just going to drop down. Done. And again, 1, 2, 3 are totally not the same. Check out 4. Let's select the longest unbroken carbon chain, but you have to select the double bond in it, right? So unbroken carbon chain in this one, and if we try to name it, this is meth eth prop. So you have the methyl right here on the second carbon. This is the methyl group right here, so it's on the second carbon. So I'll say here it's 2-methyl because on the second carbon you have methyl. And how many carbons are there? It's meth eth prop, so it's propene, but it's prop 1-ene, right? So it's not just propene, we say prop, and ene will have a number, and that number will be obviously of the position of the double bond, which is between the first and second carbon, and therefore we're going to select 1. We take the smaller number, right? So it's prop 1-ene. So 2 and 4 are the same molecule. They are both 2-methyl prop 1-ene. So 2 and 4. This is the correct option. Done. Last MCQ peeps. The displayed formula of 2 organic compounds is shown, not is. Says what are the names of these compounds? Pretty easy. That's an alcohol, so it's 1 carbon alcohol, therefore it's going to be methanol. Done. And if you check this one out, this is an ester right here. This carbonyl carbon bonded to the O. So this C double bonded to O, this carbon came from the acid, which is methanoic acid, therefore this will be methanoate. And these 2 carbons, they came from the alcohol, therefore it's going to be, they came from ethanol, so it's going to be ethyl, right? Because 2 means eth. They both came from ethanol, so it's going to change because the alcohol loses a hydrogen. And because it loses a hydrogen, the name changes to ethyl. So it's ethyl methanoate. So 2 is ethyl methanoate, therefore option number B and D are wrong. And compound 1 is obviously methanol, so A is also wrong. C is the correct option. Boom shakalaka, that's it. Hope you enjoyed, peeps. I went too slow on the MCQs. Shouldn't take you more than 4 minutes to solve all the 10 MCQs. See you guys in the next bit. Bye bye. Ciao. Allah Hafiz.